Good morning. I'm Joydeep Pal, a fifth year PhD student in the Indian Institute of Science. I'm advised by Dr. T.V. Prabhakar and Dr. Chandramani Singh. Here, I'm going to present my research work on designing tactile cyber-physical systems. Tactile Internet applications such as telesurgery require deterministic networking, which entails bounded latency in the order of milliseconds. Existing Ethernet networks with priority scheduling fail to provide latency guarantees for any traffic. We leveraged the IEEE 802.1 time-sensitive networking standard, that is, TSN, which is an IEEE standard that aims to provide deterministic networking on layer 2 networks, such as those based on Ethernet switches. It proposes a IEEE 802.1 QBV time-aware shaper mechanism, or TAS, to provide bounded latency for scheduled traffic, even in the presence of other non-critical best effort traffic, and IEEE 802.1 AS for time synchronization among connected TSN switches. The task mechanism is as follows. Each TSN switch has a gate control list, that is GCL, which is a time-slotted based transmission of flows according to its type. A Linux-based implementation called Taprio fails to provide tight latency bounds due to its dependency on latency of kernel interrupts, which varies with varying CPU workloads. Therefore, our objective is to build a programmable TSN switch using SmartNICs and programmed using P4 and microC. We leveraged the SmartNIC's flexible multi-core packet processing architecture, configurable traffic manager, highly precise clocks, and an availability of a rich set of metadata of flows. We built a testbed with one source host, followed by two TSN switches in sequence, and finally a destination host. We then send two types of flows called ST and BE from source to destination at a fixed data rate. We implement a time synchronization strategy based on IEEE 802.1 AS using in-band network telemetry to time synchronize the switches and the hosts. We compare the latencies achieved by our task-based TSN switch implementation called P4 TAS to that of round-robin, strict priority, and Taprio implementation using the testbed. Here, we show a plot to demonstrate the comparison using a cumulative distribution function of latencies experienced by both ST and BE flows. We observe that both flows experience similar latencies for round robin. For strict priority, we observe that ST flows experience a lower latency but fall short of providing bounded latency. Tapio doesn't perform well even in comparison to strict priority. P4 TAS, on the other hand, outperforms all with providing a bounded latency of 0.02 milliseconds to nearly all packets of ST flows. Finally, we show a plot for the time synchronization in nanoseconds between the two TSN switches for a duration of 15 minutes. Thank you.